being filled up with the students, the flowers are blooming. But still, this digital avenue gives us the opportunity to explore the world. And here's a classic example. Sitting at Shonarpur, Kolkata, for Team Future, we are able to have somebody as eminent as Dr. Cortesi sitting at Venice, Italy. This opportunity is just the blessing of information technology and communication. Without further ado, let us hear from the management and our patrons. Before doing so, let us have the schedule being displayed on the screen. Today's program is divided into 3 segments: the inaugural programs, the technical sessions, and the valedictory vote of thanks. Right now, we will be having the speeches from our patrons, followed by technical session 1 from Professor Dr. Agostino Cortesi. From 2:30 p.m., we will have technical session 2, Dr. Neha Sharma, and then from 3:30, we'll have the vote of thanks. So without further ado, let us welcome our founder director, Madam. We know she is really busy with a very, very tight schedule, but we are indeed thankful and indebted to her that she has managed time out to be present in this program. Let us give a big round of applause in welcoming our Honorable Team Future Founder Director, Ma'am, Dr. Moshumi Ghosh. May we request her for a brief welcome message. Let us welcome Dr. Moshumi Ghosh. Ma'am, may you please take over. Dr. Moshumi Ghosh, Founder Director, Ma'am, Team Future. We believe she is present in the meeting. I request the organizers for a confirmation. Dr. Moshumi Ghosh, she was present in this meeting. I'd request her to kindly. Right now, it seems that for some reason she has lost connection. Actually, she told that she will be in transport. So at times she may lose the connection. So in that time, we have the privilege of having a video message from her, which she actually delivered for us to motivate us. May we have the video message played by Dr. Moshumi Ghosh. I think there is a problem with sound. The technical support team, could you please take it? There is a problem in sound. May we please replay it? May we please relate? May we please relate? Technical problem in sound. Is it coming? Is the voice coming? The voice of Madam is not coming. I request this video to be replayed once again.
Areas and sweeping new concepts in the fields of
so please start from the beginning. Please start from the beginning.
Welcome to Future.
We are streaming this in live, so there might be some
long lecture series by Team Future. We're starting it today, and the objective of this program is to widen our ecosystem and make all of us aware of the new emerging areas and sweeping new concepts in the fields of software and associate fields. This lecture series, to begin with, is being organized by the departments of Computer Science, Data Science, Information Technology and Computer Applications, and I'm sure it's going to spread to our all other departments, and our team members would be engaged. In fact, today's domain is artificial intelligence and data science. This reminds me of a movie that I've seen lately. I'm sure some of you have too, which is Moonfall, where an unknown source of artificial intelligence is trying to knock out the moon from its orbit, and if that collides with the Earth, we are gone. That's fiction, even today. Will it remain a fiction? Whatever we thought of fiction, has it become a fact now? Today, in fact, you can own a piece of land on the moon. And your valuation would depend on whether you want mountains, or you want the sea, or you want the lake, or you want the rainbow zone. So, unless we are tuning ourselves, students, faculty members, all of us involved with the educational or academic ecosystem and the professional ecosystem, unless this tuning is there, whatever we think is fiction will turn out to be a fact without we being very, very aware about it. So it's high time that all of us absorb this content, which is going to be very, very rich. And data again is the lifeblood. And it is data which is going to rule the world. It is ruling the world. And therefore, unless we can grasp the patterns, we are out of the race. It doesn't depend to which particular discipline I belong. All of us will be carried away with this sweeping change. I would like to call it the difference between yesterday's fiction and today's fact. We need to be with facts, and that is the purpose of Future Plus Plus. I have the privilege of welcoming Dr. Agostino Cortesi and Professor Dr. Neha Sharma today for the first session. We would presume that we would have these sessions fortnightly throughout the year, so that at least we'll get about 20-25 sessions in this academic year. All of you, be with us, stay tuned, and join us today and in future. Thank you so much today from Team Future. I'm Dr. Moshini Ghoshia, founder of the team.
Thank you very much for your inspiring words. Yes, as always, you are the source of motivation for all the team members of the esteemed brand Team Future. Let's put our hands together once again to thank ma'am. Big round of applause, please. Thank you. Please mute yourself. It's my pleasure. It's my pleasure to announce to the audience we have both the speakers, Dr. Agostino Cortesi and Dr. Neha Sharma amongst us. Both of them have presented themselves in spite of their busy schedule into this inauguration ceremony. Now let's move on to our respected, beloved Executive Director, Sir Dr. Alok Kumar Ghosh. It's my privilege on behalf of Future Plus Plus to welcome Dr. Alok Kumar Ghosh to deliver the opening address on behalf of Team Future. So let's join once again in welcoming our very own ED Sir, Dr. Ghosh.
Thank you, Professor Shantanu. Good afternoon.
Thank you, sir.
On behalf of this institute, I welcome you all here today in this international seminar on recent trends in software management and machine intellectuality, organized by the Department of Computer Science and Engineering, Data Science, IT, and Computer Applications Department, that is MCA and BCA department. In fact, machine intelligence, it has started reshaping the world in all the areas, maybe in the healthcare, maybe in the teaching profession, judicial services, everywhere. Basically, it helps us to take the unbiased decision because of its reliability, no risk, zero error, and it is coming out or accepted in all the fields. Definitely, our recent pandemic taught us so many things. Even not coming to the workplace physically, It has taught us how to connect together and how to carry out the day-to-day activities. And definitely, as Professor Shantanu Rai has told, that sitting in Calcutta, we are fortunate enough to have Professor Agostino Cortesi and Dr. Neha Sharma, even sitting in the corner of India. We are fortunate enough to have them today. And our students are also fortunate enough to listen the recent trends on the software management field from the stalwarts. After 2 years, recently our campus has been started, and we started seeing the lovely face of our students again. And there is, yes, all the departments have cheered up, and they have started healthy competition to organize like this seminar, uh, workshop, and all the activities started either physically or virtually or through webinar like things. Almost all the departments they have started. It's a very good sign. We are honored here to have with us Professor Agostino Cortesi, University of Ca' Foscari, Italy, Venice, and Dr. Neha Sharma, Founder Secretary Society of Data Science, here with us today. Thank you, sir and madam, to accept our invitation and be with us today in this webinar in spite of your busy schedule. I am sure we will be enriched with the knowledge after completion of this event. And I once again welcome you all in this event and hope we will have a great time ahead. Last, not the least, once again, I congratulate the team members, definitely Professor Tapos Rai, Professor Shantanu Rai, Professor Anirban Chakravarti, head of the Computer Science, Computer Application Department, Professor Bashu from the IT department, and all the teachers, staff members, students of the departments, those are directly or indirectly involved to start this event. Thank you very much. Thank you, sir. Once again, thank you, sir and ma'am, to be with us. Thank you. Wish you all the best. Thank you.
Thank you, sir, for your kind words. As we always keep saying in Team Future, you are the big banyan tree under the shade. We are always taking inspiration from all of us. Thank you, sir, for being with us. Your constant support will be the pavement for our future progress, future plus plus. Now, before we move on to our technical session one, I'd like to invite the stalwarts of this event itself, the backbone of the event itself, Professor Taposh Roy, head of the Computer Science and Engineering Department, Future Institute of Engineering and Management, to prize us about Computer Science Engineering Department, about the program Future Plus Plus, about the lecture series, and the vision of CSE in carrying this baton forward. I'm privileged to welcome Professor Taposh Roy. May you take over, please, sir.
Respected Executive Director, sir, esteemed guest speakers of today's session, my colleagues and my students, and all other participants of the event. A very good afternoon and a warm welcome to you all to this Future Plus Plus lecture series. Department of Computer Science and Engineering started journey in 2002 at FIEM, and then in 2014 the department commenced its journey at our second campus, FIT, and in 2020 some more CSE allied departments like CSE Data Science, CSE Artificial Intelligence and Machine Learning, CSE IoT Cyber Security with Blockchain Technologies also commenced their journey under the Team Future banner. Vision of the department is to build good engineers and make the students market or business ready so that the students can crack the placement opportunities come across towards building the stepping stone of their professional career. Above this, the department makes the students a very good human being who is capable of handling any kind of challenges in life. Achievements of students of CSE departments are in galore. Such achievements are in the curricular, co-curricular, and extracurricular activities like organizing project and coding competitions, lecture programs on recent technological developments, etc. etc. Team from the CSE department came out as the national level champion in the Smart India Hackathon tournament, which is a national event in 2019. And the teams from the department went into the finals rounds of 2000 in the same event in 2017 and 2018. This Future Plus Plus lecture series is an initiative of our Team Future. We will organize programs covering faculty and student development, career counseling, and of other techno management areas, which will be beneficial for both teacher and student fraternity. Let me take this opportunity to express my most thanks and gratitude to Director Madam and Executive Director Sir for their continuous support and encouragement to us. I am also thankful to all my colleagues and students for their synchronized and harmonized efforts to make this inaugural program possible. I wish Future Plus Plus lecture series a great success. Thank you.
Thank you, sir, for your inspiring words. Yes, indeed, CSE department has been the cog in the wheel of Team Future. It is making us enabling of fast progress. Step by step progress is the essence of Future Plus, moving one step at a time. Your guidance, your motivation, your inspiration, all are equally needed to carry us forward, to give the inspiration to carry us forward. So let's thank our very own Professor Taposh Roy, sir. Now it's time for us. Mute yourselves, all of you. Now it's time for us to move on to technical session one, where we are honored to have Professor Dr. Cortesi, sir, amongst us. He needs no introduction in the fraternity of teaching, learning, research, software reliability. And it's my proud privilege, just for the customary introduction, to introduce Cortesi sir himself. May we have his profile, his distinguished profile displayed on the screen. As they say, data is the current fuel. And as fuel in natural environment spreads pollution, data is also spreading pollution. So where is the measure? Security, reliability are the measures to combat the problems with data, with software. And sir will be deliberating on software reliability. To begin with, Professor Cortesi is a professor of computer science at Ca' Foscari University, Venice, Italy. Currently, he holds the chairs of software engineering, program analysis and verification, computer networks and information system, and data programming, and works in several research projects such as static security analysis in IoT software, verification of smart contracts in blockchain technology, extensive research experience in the area of static analysis, software verification techniques. His main research interests concern programming languages theory, software engineering, and static analysis techniques, with particular emphasis on security applications. He coordinates H2020 Families Share Project and the MAA Italy India project, formal specification of secured software system. He has been the advisor of several doctoral, postdoctoral students from Italy and abroad, that is India, Cuba, and has published more than 150 papers in high-level international journals and international conferences. He has served several times as a member or chair of program committees of international conferences like SAS, BMCAI, CSF, CCM, ACM, SSC, and he is in the editorial board of Journals of Computer Language, Journals of Universal Computer Science. The list is quite a big one, and we tried to bring it in the atomic state. It took 2 minutes of time. So without further ado, it's my privilege on behalf of Team Future, that is Future Institute of Engineering and Management, Future Institute of Technology, to introduce and to be elated to welcome Professor Dr. Agostino Cortesi. His top topic of his talk today is challenges of software reliability. So let's welcome Dr. Cortesi by giving him a big hands, and may I request Dr. Cortesi to please take over the session. We will be having a Q&A question answer session following this. So keep your patience. Obviously, we will have questions. We will listen from him. So it will be a great pleasure and a great opportunity to enrich our knowledge. Sir, can you please take over? Please join me in welcoming Dr. Cortesi.
Okay, thank you very much for your very kind introduction. And before starting my lecture, I would like to thank again the patrons and the conveners of the Future Institute of Engineering and Management. I'm very happy and glad to be here with you. Actually, I would like to be present in India these days, but because of COVID, it's kind of difficult for me to move there. So before starting the lecture, I would like just to tell you that I'm really very worried about the situation in Ukraine. Everybody knows what happens there, and I think that as scientists and people who believe in the power of reason, we must make our voices heard so that our governments do what they can to stop the war. So I think that it's very important to be aware of the power that we have also in this okay, let me just share my screen. I cannot share it. You should give me some privilege, maybe, Shantanu.
Sir, yes, sir. Sir is having difficulty in sharing his screen. So can you please allow him to share the screen? Sir, we have given the privilege. Can you please try again?
No, I cannot share it. Let me just check again. No, it's not possible to share it. I don't have privileges.
Sir, the technical committee is saying that they have given you the privilege. So would you please
reload again? Let me just check again.
Prashanto Mojumdar is presenting. Please stop presenting. Sir, is it working?
No, not yet. Okay, let me just...
could you please leave and rejoin?
Yeah.
It may work. Students, make sure sir is given. Leave করেছেন উনি আবার রিজয়েন করুন কেন কি হলো allow করো স্যারকে
Let me try again. No, doesn't work. Okay.
It is not working, sir?
No, it doesn't work. It doesn't. It
tells that from our system, we are seeing that yes, we can share the screen.
Yeah, let me just check my system preferences.
Actually, one of my faculty members had just shared the screen, and it was possible for him. Can you please take?
Otherwise, what I can do is I can just send you the slides by email, and you can project them.
Yes, sir. Yes, sir. Sir is sending the slide. So please, the participants, we are having an issue. So I hope for your patience.
Yeah, just 1 second.
Sir is mailing me, so somebody please come in and mail it to the account, to your account.
Okay, I sent them to you, so it's a PDF. Maybe you can.
So can you please once again try? You are sending the mail fine, but the organizer is saying that we should not have any issues because we have tested it multiple times. Can you please try once again, sir?
No,
No, it is not working.
no, it doesn't work. Okay, so it's better that you project them, and I just tell you when to go to the next slide. Okay. I apologize, really.
Yes, sir, we have received your mail and we'll be very soon displaying it on the screen. So in between, I have few questions. To you. I mean, what is the condition over there in Italy? Means a couple of years ago when this pandemic set in, we got the news in the news, various news channels, papers. The scary visuals were coming out from Italy. What is the condition over there right now, sir?
No, at the moment things are getting better on this in this direction, in the sense that basically the spreading of the virus is getting under control, and I think that the university already reopened since the beginning of the year, and we are giving lecture in class, and the situation is almost normal. Okay, let's say that we are. At the moment, we are just taking full benefit of the fact that we are able to register lectures and do giving material recorded to students and so on. So, but we are hoping that by summer everything will be again in a normal situation. Yeah.
Sir, can you please once again check? You have been made as co-host.
I check once more, sure.
Yes, sir. Yes, sir. I'm sorry, sir. But
No way. So please share the slides and I start. Is there any problem?
Technical delay once again, participants. You were saying that we're having a technical problem where we are sharing, sir. We are sharing screen. I mean, the presentation is being shared. Yes, sir. We have just downloaded the slide, and in a while, in a couple of minutes, in a couple of seconds, maybe we will share the screen. We are almost onto it. Now you can see that the screen is being shared. I'd request the students to carefully listen to sir when he asks us change the screen. Thank you, sir.
Okay, so
Yeah,
I can start. Okay, I think that you can make possibly in the presentation mode instead of so that you can just move it to one slide to another. Anyway, okay, so the title of this talk is The Challenges of Software Reliability, and you may move to the next slide. Just okay, there are just a couple of pictures of the main buildings of our university. So the University Ca' Foscari is located in downtown Venice. It's that palace in front of the Grand Canal is the main building of the university where the rectorate takes place. And in the rightmost picture, you may see the scientific campus where the computer science department is located at the moment, which is in the mainland. So the similarity between Venice and Calcutta is given by the water, so you have water during the monsoon season. We have water almost every day. Okay, let's move to the next slide. It was just to yeah, next slide, please. Shantanu? Okay, I
Yes,
think that
sir.
we can skip it. Because, yeah,
Yes,
because
sir. We are
it was just
there.
a
Yeah.
quick recap of my history. No problem. Let's go to the next one.
Next one.
Yeah. Yeah, because I just wanted to say that I'm very glad to be here today, because we have a very long-term collaboration with India institutes. In particular, since more than 15 years, we are in touch and in good contact with the University of Calcutta, with Professor Chaki, Rituparna Chaki, Shomer Sen, Shankan, Chuduri, and also in that in that setting, I also had the great opportunity to work also with Shantanu Roy. But at the moment, as we had several visiting PhD students and postdoc students in Venice, now at the moment I have a lot of further contacts with former students of mine that are now in IIT Vadodara, in IIT Patna, at SRM University in Amaravati, at NIT Durgapur. And okay, since I'm very happy now that also with the Future Institute of Engineering and Management, we can have a sort of collaboration. Okay, next slide, please. Okay, yeah, because I would like to start this speech by some very, very trivial observations. So the first evidence is that everybody knows that whenever we download a new software, we are quite sure that there will be some bugs and some problems that sooner or later will arrive. And the second evidence is that even though we are good programmers and even though we are quite attentive in the way we are using programming languages, it occurs very often that our personal programs had several runtime errors. Okay, so after these two evidences, one may conclude that finding bugs is not important because we cannot get rid of them, but we would like to have an alternative approach. Okay, next slide, please. Why? Because the reliability of software is an issue all over the world. It costs a lot of money, so it was estimated that the cost of software bugs costs just only to the US economy about $60 billion each year. And we have not only a cost, but also a risk associated to software reliability, which is increasing and increasing, because the worldwide economic loss caused by all forms of software attacks, security attacks, is about 50 billion dollars. And this cost is caused basically by attacks that refer to vulnerabilities of the software which is shared. Okay, I can give you these slides and you can share them with the students. I have just a couple of pointers to what is the role of software in accident in spacecraft and what is the history of the software bugs in the last decades. And out of them, you see that really we should take care of this problem in a proper way. Next slide, please. In particular, there are two disasters that are particularly interesting. One occurred in 1986, the failure of the Ariane 5 spacecraft, and in that case, the reason for the destruction of this spacecraft was due to a very stupid issue. The fact that at a certain point, a conversion from a 64-bit floating point to a 16-bit integer with a value that was larger than the values that are possibly stored in a 16-bit integers, basically that overflow caused an hardware trap, okay? And another example is in 1998, a Mars climate orbiter, so it took several years to get to that spacecraft to Mars, and it was lost in space. Just because of a very stupid bug due to the fact that part of the software was written in English and a part was written in the United States. They were using different unit to metric. So on one side, we use the English imperial unit, and on the other side, the metric unit. And just because of the incompatibility, basically, of the meaning assigned to values, the orbit was completely lost. Okay, so these are just examples of how very specific and let's say quite trivial bugs may really be costly for the community. Next slide, please. Next, please. Yeah, and one may wonder, are we getting better in the years? No, the previous one, please. Okay. If we look at the last 10 years, we see what are the number of security vulnerabilities that are detected in the open source GitHub repositories, what we can see is that the number of vulnerabilities is not getting less, but it increases year by year. And it increases, if you look at this picture, in almost an exponential way. And the next slide, please. The bugs, do they depend on the programming language? Partly yes, partly not, in the sense that there are programming languages that are more less keen to contain, to lead vulnerabilities, like Ruby, for instance. But if you look at the percentage of open source vulnerabilities per language, basically what you see is that the distribution almost reflects the actual distribution of the software with respect to the languages. Okay, so it's not a matter of which language you choose in order to face this problem. Next slide, please. Okay, so in order to ensure reliability of software, basically what we want to assure is to provide some tools that support the correctness about the program, in particular correctness with respect to some properties of the program that you want to fulfill. And we have to deal both with functional correctness. So what we aim is that to prove that the software satisfies the specification. And on the other side, what we want is that there are also absence of non-functional errors. So you want that space constraints are satisfied, that no runtime error should occur, that time constraints are satisfied, and so on. And in order to guarantee the reliability of software, we need guarantees. Okay, so we need tools that support the fact that, okay, I can trust my software. Next slide, please. Okay, so what is the starting point? Okay, what is a software? What is a program? A program basically can be seen as the specification of a possibly infinite number of executions. Okay, so what we can say is that if I have a program that has just one single variable, I can look at the value that are stored at each time point in that variable and see the trajectory of the execution of the program starting from a given initial value. And so basically how we can see the program as a possibly infinite set of the execution traces that it represents. Okay, so, and in that respect, what means what is the meaning of a functional verification? Next slide, please. The fact that, so what we want to verify is that these trajectories, so this possibly infinite set of trajectories, never intersect some forbidden zone. So some areas that are recognized as not let's say, compliant with the specification or with the non-functional requirements that we would like to consider. So we need some approaches that allows us to say, okay, I am sure that none of the trajectories gets trapped in the red zone. Okay, that's pictorially what we aim to do. Next slide, please. So the bad news is that there is no solution for that. Okay, what we like to expect is to have some methods that are automatic so that they do not require human interaction. They should be powerful in the sense that we want to be able to prove non-trivial properties on one side, and we want also to tell something interesting about non-trivial programs. We would like to have a sound approach in the sense that we would like to be sure that the result of the verification never forcibly claim correctness. So what is said by the analysis, by the verification, can be fully trusted. And finally, we have a last aim, which is possibly we would like that the analysis is complete. Okay, so that the property I want to be guaranteed is always captured by my analysis. But unfortunately, there is a theoretical result by Rice that says that all non-trivial properties of program behavior in a Turing-complete programming language are not decidable. And the stability of a property means that there is no automatic verification method that might be both sound and complete. So that may always give you a sound and complete answer. Okay. Okay, but we are used to develop software and we are used to use testing, right? But unfortunately, testing cannot be a solution for that. Why? Because if you look at pictorially of the presentation that we gave before, what means a test activity? It means that you are just selecting a finite number of traces and you are just checking them. Okay, so if you are lucky, so if your program is buggy and you are lucky enough to find out a trace that intersect the forbidden zone, okay, your testing activity is successful in the sense that it find out a vulnerability or a bug. Okay, but if you are not lucky enough, you make a testing activity, you just consider a finite subset of the execution traces, but the result of it cannot give you any guarantee of the fact that every execution of the program doesn't get into a forbidden zone. Okay. Next slide, please. Okay. Yeah, and there is this important statement by Dijkstra in 1970 that says that program testing can be used to show the presence of bugs, but never to prove their absence. Okay, so basically, testing is a verification technique that can be, of course, that should be used, but it does not guarantee the soundness of what you say at the end of the verification. Okay, next slide. Okay, so we have to choose what to give up. Okay, we said that we want to have something which is automatic, sound, complete, and powerful. Okay, so of course we would like to have something powerful. We don't want to give up soundness. Okay, and then we can either give up the fact that the method is automatic, or give up the fact that the result of the analysis verification is complete. Okay, and with respect to this choice, basically we have different approaches. If we give up, if we renounce to be automatic, then we have a deductive verification and interactive theory proving as techniques. If we are accepting not to be complete, then we can use data flow analysis type systems or absent interpretation as a technique. And in the rest of my talk, I would like just to show you something about these different approaches. Okay. Next. Okay, the first, so if we accept, okay, not to be automatic, then we can use a deductive verification that has a problem that cannot be automatable, that requires a very complex user interaction, and that basically it works fine in academic setting or for very specific very small slices of code. Actually, there are some good examples of deep use of this kind of approach, which is, for instance, the CompCert, which is the first verified C compiler. But next slide, please. The issue with deductive verification is that it requires that the programmer explicitly annotates the program with loop invariants, pre and post conditions, and only once this activity has been performed, then the automatic part can take place by using SMT solvers or other Turing proving methods. Okay. This is something that may make students worrying, in the sense that it's already difficult to write programs to use another language, higher level language, to express in a formal way the properties that you want to be guaranteed by every execution of the program requires an additional effort that might be too hard for programmers. Okay, and that's why the usage of this approach is valuable, but it cannot be applied to large portions of software. It would be too much costly, and of course, it would require also a careful verification of the correctness of the loop invariants and the pre-post condition. So it would require a second order verification, which is even more difficult than the verification of the code itself. So that's the first solution. And then next slide, please. Another solution that in the, let's say, interactive approach is to use tools like CodeSonar, BugFinder, Coverity. So these are tools that are available for free or by payment that are aimed at finding as many bugs as possible in a short time, just by looking at patterns, at language patterns that may be associated to possible errors. Okay. So, for instance, you may have these kind of tools may check if the variable is used without being initialized. Okay, they can be also smart enough, for instance, to detect that if the variable is initialized only if a condition which is always true is applied, then it's okay, so there is no bug inside. But there is a limit of these approaches in the sense that they are not necessarily sound. Okay, there can be false negatives. There can be programs that pass the verification, but that may contain bugs and actually contain vulnerabilities that may be exploited into attacks, or that may cause the unreliability of the program. For instance, in the last example that you can see at the bottom right of the slide, okay, here you have an array, and when you are looking at the indexes of the array, you get to the last element, but you also consider an element which is not in the array itself. And this kind of problems cannot be captured by tools like them, in the sense that there is no way. So it would require a sort of semantic analysis that is not performed by these kind of tools. Okay, next slide, please. Okay, so the other approach, the fact that we want, if we want to be automatic on one side, but we, let's say, renounce to completeness, so we want to keep soundness, but we accept that there might be some false positive, as a pictorial representation, what you see in the slide. Okay, so basically, if I'm able to prove that all my trajectories are over approximate by the green zone, and that the green zone does not intercept the red zone, then of course I'm guaranteed that none of my execution trace will get into a trouble. Okay. Sorry, Raul, can you switch off your mic? No, thank you. Okay, so the idea is that, okay, of course, the green zone may be, may over approximate, may consider also possible execution traces that are not actually in the set of trajectories of the program. But if we are able to be precise enough to compute this over approximation, then of course, this is a method, okay, that guarantees soundness of the verification. Okay, next slide, please. Of course, what is main problem with the approach that might be false alarms. Okay, false alarm occurs when you are not precise enough in your over approximation, so that the green zone intersects the forbidden zone, even though no execution path actually get there. Okay, and so in this case, what we can do, okay, we can try to understand in which particular circumstances you may get there, and then we may check if the alarm is a true alarm or a false alarm. And if it is a false alarm, then we can say, okay, the program is correct, as the false alarm, the alarm was due only to the over approximation, not to an actual occurrence of a trajectory that gets into the forbidden zone. Okay, next slide, please. Okay, so of course the requirement for these kind of approaches should be to ensure the soundness. Okay, so the green zone should cover all the traces. It's if you provide a static analysis solution that leaves some execution uncovered, then this is not an acceptable solution. Okay, next slide, please. And the second point is that you have to be sure that the complete trajectories are covered, not just an initial segment of them. Okay, so you know that the program may also run forever, and you are asked to be able to over approximate also infinite executions, okay, in a way that in order to guarantee the soundness of the approach. The initial segments cannot, of course, guarantee anything. Okay? Next slide, please. Okay, so let's see a simple example. So we have this program, and we know that in any program that deals with integers, if we divide by 0, you may get an error, okay? A runtime error. Okay, so the question is, can we get an error in the fourth line of this program? Next slide, please. Okay, so what we can do is just to consider all the possible execution traces. So if we start giving as an input 0, then we may see what is a trace, okay, that says that at the beginning x is 0, then you introduce y, then, and so y has, we don't know what is the actual value assigned to that variable. Then you assigned a value to z, and then when before returning y, you know that the state of the memory has 0 in x, 0 in y, and 1 in z. Okay, and this trace doesn't cause any problem. Then we may move to the next trace. Next, please. Okay, so we start by 1. Okay, we have another trace where you can have other values at each step in the execution of the program. Okay, and then next slide, please. Okay, and then we can consider the infinite set of all the concrete traces. Okay, and if we start enumerating them, you acknowledge that there is, in none of the traces, you can get into a faulty problem. Okay, so what does mean testing in this sense, in this case? Testing would mean, okay, I just pick a finite number of initial values and I test the program. It says nothing. But look at that. Next slide, please. Okay, look at that. If we just consider a partition of the integers into by looking at the parity. Okay, so a number can be either even or odd. Okay, you may know nothing about a number, and in this case, you may say that any represents any number. You don't know what is if it is even or odd. Okay, and then you can have another representation of something which is not a number. Okay, so you can consider a representation of the integer numbers in by this simple poset. Okay, and then we can say, okay, we remember that if we make a sum of two even number, you get an even number. If you make the sum of even number with an odd number, you get an odd number. And if you multiply any number with an even number, you get an even number, and so on. So you have some rules that corresponds to the behavior of the arithmetic operations on the parity, independently on the actual values of the variables. Okay, next slide, please. Okay, and so let's start considering this program again. If I call this program, I can call it either by an even number or by an odd number, because any input number is either even or odd. Okay, so assume that x is even. Then when I initialize y, what I know is that y is any number. Okay, it is not, it has just been introduced, not given any value. Okay, so y is any. And when I say that, when I assign a value to z, which is 2 times x plus 1, as I knew that x is even, I can conclude that after the third line of program, for sure, z is odd. Okay? And when I assign a value to y, I multiply x, which is even, times 10, which is even, divided by z, which is odd. Okay? So what I get there is that, okay, y is any. Okay, I cannot conclude anything about the parity of y. But what I know is that in this case, when I apply the assignment y is equal 10 times x divided by z, okay, I'm sure that if at the beginning x was even, then z at that point is odd. Okay, and look at the second case. We start by x is odd. Okay. Also in this case, if you just go through in a similar way, you get that also in this case, when you call the assignment y is equal 10 times x divided by z, also in this case, z is odd. Okay. So we have just two traces to consider, because there are no other possibility. Either x is even at the beginning or x is odd. And in both traces that we consider, that are abstract traces in the sense that we are not considering actual values of the variables x and y and z, but just values into this abstract representation of the concrete value. But as these two abstract values, abstract traces, cover all the possibly infinite concrete traces, and I'm sure that in both cases that is odd when I call the statement y is equal 10 times x divided by z, then, next slide, then I can conclude that this program never gets to a bug, okay, to a vulnerability due to the divided by zero. Okay, and that is a sound result that we can get. Okay. Okay, next slide, please. So a first approach in this direction okay, to over-approximate the trajectories by checking that the execution traces are contained in a green zone that does not intersect the red zone. A first technique is called type systems. Okay, what type systems means? It means I give you a number of rules that should be satisfied by the program, and I can prove that every program that satisfies these rules do not get troubles, okay, do not yield to any trouble with respect to a property which is captured by that type system. So the rules, of course, depends on the property you want to verify and on the language. Okay, so for instance, you can see in the example at the right of the slide that you can get a different result when you are considering a language which has a static binding instead of a dynamic binding. When considering the possible misuse of a call of a method, okay? But what is important is that the type system approach is a prescriptive approach. So I design a number of rules, I check the program against these rules, and these rules are just giving us the prescriptions, okay, that allows me to tell that a program is correct with respect to that property. But they are not getting information out of the program. They just check the program against some rules. Next slide, please. Okay, another approach is data flow analysis, okay, where you consider, instead of the program, the control flow representation of the program, and you make explicit, you formalize the analysis in terms of two mutual recursive equations, and an algorithm that computes the fixed point of these mutual recursive equations that represent how the single statement of the program modify the state of the computation with respect to the property captured by the domain that you are using during the analysis. Okay, and so liveness analysis, constant propagation analysis, taint analysis are examples of data flow analysis that are sound approaches. Okay, with respect, but that require basically these two elements that are specific: the fact that you are not reasoning on the program, but on a representation of the program, the control flow graph of the program, and that you need a fixed point algorithm that should ensure you the termination of the analysis in order to get something that is valuable. Okay. Next slide, please. Another approach, which is the one I'm working in particular, is absent interpretation. That means, okay, instead of considering another representation of the program, so the its control flow graph, I just use the program itself, okay? But I look at the program, interpreting each statement, not in the standard meaning with the usual operation, defined arithmetic operation, but on abstract operations that are a safe approximation of the behavior of the concrete operations on the values that are represented by abstract values. Next slide, please. Okay, so what is the idea? The idea is that, okay, I can represent formally the concrete executions of the complete traces of a program, okay, as small step transitions from one state to another. So I have a representation of the concrete semantics of the program in these terms. Next slide, please. And I make an abstraction, okay, of this computation by considering elements that over-approximates a set of states. So basically, instead of considering the single traces, okay, I consider one or a finite number of traces that just have as starting and ending point at each step an over-approximation of the actual concrete states of computation of the program. Okay, so instead of considering the single arrows, I consider just the red arrow that maps one set of states to the next set of states that may be by considering also elements that are not actually reached by the actual computation. Okay, next step, please. Okay, we can do it by using algorithm that are fixed point algorithm that in a few steps may reach the over approximation of the whole area. Okay, of course, for instance, if we get something like the one the situation which is depicted in the slide, okay, in just 3 steps, we may say, okay, look, the 2 forbidden zones at the top or the bottom are never reached by any execution of the program. Okay, but we may still have some false alarm inside. And so at this point, what we can do, next slide, is, okay, I can refine this approach by do trace partitioning. Okay, so by splitting the over approximation in a way that it better captures, okay, the behavior of the actual execution traces. But you see that in reasoning in terms of these over approximations allows us to solve the problem in a sound manner on one side, and ensuring the finiteness, okay, of the analysis in the sense that as we are reasoning in terms of over approximation of values, the convergence in the abstract domain may be guaranteed easily. Okay. Next slide. Okay, so what we need for that, we need a formalization of the semantics of the programming language, as we have to reason about the language. We need to develop different domains to capture properties of interest. So in particular, if you are interested into numerical issues, you need domains like intervals or linear inequations to manage them. We need operation that sound approximates the basic statement of the language, and we need a way to ensure the convergence. Okay, and if you are dealing with infinite abstract domains, then you need a particular convergence operator called widening that ensures that in any way, after a finite number of steps, you get to what you want. Okay, next slide, and we are almost concluding. Okay, so this is an area which is extremely active, also by a research point of view. There are several conferences in worldwide that are reference conferences for that. So BMCI, TACAS, and SAS in particular, and journals like Science of Computer Programming and ICM Toplas that gives a lot of space to this kind of issues. Okay, and next slide, please. And yeah, and in this area, we are working quite actively, in particular on developing analysis for strings, okay, so managing text, to develop analysis that allows us to prove the reliability of systems that uses different languages. We are also interested on dynamic languages, for instance, Python, that makes some challenges to this kind of approaches. And last but not least, we would like also to specify the analysis on particular non-functional requirements in order to bring the gap between the specification and the verification of software. Next one. Yeah, and this is just a list of the very last publications where you can see that we are actually studying analysis for IoT vulnerabilities, for string domains, for translating analysis from one language to another, so for .NET to Java bytecode, for instance, to systems that interact also with database application and so on. You can see that there is also some paper written with Shantanu on issues that are not strictly related to software verification, but that are relevant anyway. Okay, that's all what I wanted to tell you, and I'm here open to questions if there is anything that you want to discuss. In the next slide,
thank you, sir.
My address, maybe my email address, if you please.
Next slide, please. Yeah. Thank you, sir. Actually, the whole session was, I mean, the first thing is you have been immaculate in terms of time adjustment. We had a 10-minute delay, but you actually have covered it within your time. Yeah, sir. Thank you very much, and sorry for the interruption to all the participants and the guests. We have a couple of minutes to take some questions. Please raise your hands if you have some questions. Please raise your hands if you have any questions regarding sir's session. We have a joint convener, Professor Devjyoti Basu from the Department of Information Technology. May I request sir to pose his question, please.
Thank you, sir. A very good session. I have one question, one very basic question, that is there any relationship or is there any probability between the failure of a software with a specific programming language? That means a programming language having so many punctuation marks or something like that. Is there any probability or relationship between failure of a software with a specific programming language?
Yeah, of course. In the sense that if you have a programming language like C++ that allows you to have a multiple inheritance, that is one of the possible causes of problems. Of course, the programming language is more keen to be vulnerable or contain bugs that are very difficult to detect by static analysis techniques. Okay, if you have a strongly typed language, of course, you may limit the occurrence of bugs related to wrong typing. Okay, if you have dynamic language that allows you to assign values belonging to different types to the same variable, that may be a cause of bugs. Okay, that is can be avoided by using languages that has strict types. Okay, so it is true what you said. In the choice of programming language, of course, you may also look at these issues. On the other side, it is true that there are languages that are so not most of the time you are not deciding which language to be used. Okay, in the sense that you are most of the time building your software on top of some other software written in a specific language, and you have to adapt to it. And so you have to be aware of the fact of also of the weaknesses of the language that you are using.
Thank you, sir.
Thank you, sir. We will take one more question if you have any, because our next speaker is waiting for us. So, do we have any more questions? Please raise your hands. If you have any more questions, I'll take it. It seems that nobody has any questions, sir. So before we conclude and bid our final thank to Courtesy sir, it's my privilege to request joint convener Professor Prashanto Mojumdar of Computer Science and Engineering Department on behalf of the organizing committee to invite you in our premises. May I request Professor Mojumdar to please pose a request on behalf of us.
Thank you, Shantanu. Welcome, sir. As we express our grateful gratitude to you for this such a wonderful session which you have performed right now, and that it is not only this will enhance our knowledge as well as we want to be a partnership with you, and so that's why we would like to invite you to our college in our next visit to your India. We are expecting your presence in our college. Thank you, sir.
Sure. Thank you.
Thank you, Tino sir. Yes, indeed. I mean, that was a kind gesture from you. Yes, sir. We are very much thankful and indebted to you. So it's time for us to move on. We can see Neha ma'am already lined up. We can see her. So I'd request our convener, Professor Proshenjit Boshu, Head of Information Technology Department, FIEM, to apprise us about the Department of IT and the Vision. And please welcome our Honorable Neha Sharma ma'am as the guest speaker. Professor Boshu, may you please.
Thank you, Shantanu. Very good afternoon to our Professor Dr. Computer Department of BCA, Dr. Nash Consultant Disease Chairman, Mr. Shilajit Ghosh, our founder director, Madam Dr. Mousumi Ghosh, our Executive Director, Dr. Alok Kumar Ghosh, our dear students and fellow colleagues. As Ms. Hilary mentioned, data scientist and founder of Fast Forward Lab said once, the core advantage of data is that it tells you something about the world that you didn't know before. Truly, in our daily life, or I maybe whatever age I have, from 8 to 18, I am totally driven by data, setting my song preference on YouTube to provide information about new drugs for Alzheimer's diseases for my dad. Now, this is the era when we call data is information, and I know information is power. As power as it comes, different risk factors. It is not like some banking information I am sharing. It is my personal confidential information, my choices, my likings, dislikings, everything is now open to someone or some softwares and become vulnerable. In today's session, we have been already enlightened by the speaker, Dr. Agostino Cartesi, in this area, and we're eagerly waiting for Dr. Neha Sharma's speech, which surely enriches us in many ways. Being a IT department, I'm very much thankful to them for their talk. From 2007, when the IT department started its journey, it had a dream to create such an academic environment that not only prepares students for job ready, but also boost the students for higher study, contribute to research area, etc. That is why we have amazing placement records, along with having university toppers in national level exams conducted by IITs, etc. For the last few months, we have organized webinars in the placement journey as well as organize webinars for preparing Get with collaboration of Unacademy. WebEx is now our ongoing web workshop series that helps students with a guide to full stack web development. For for conducting this event, sorry, we have a team of students and faculty members, and we are very eager to organize such events with our maximum ability in future. Enjoy these events. Thank you very much. I am handing mic over to the Shantanu. Welcome, ma'am.
Ma'am, it's been quite a long wait. In fact, almost 555, almost triple five. I've just checked it before. Almost more than 550 participants or visitors are looking at this concurrently. This is going into huge magnitude. May we have the distinguished profile of Neha ma'am to be displayed on the screen. I'd request all of you to please turn off your videos, those who are doing it. May I have the distinguished profile of Dr. Neha Sharma shared on the screen. Yeah, it's being presented. And fingers crossed, Neha ma'am. Hopefully, you will be able to share. Currently,
I'm sure.
Dr. Neha Sharma
Yeah.
is consultant in TCS and founder secretary of Society for Data Science, alumnus of the Premier College of Engineering and Technology, Bhubaneswar, and completed her PhD from the prestigious Indian Institute of Technology, Dhanbad. Besides, she is the brain behind conceptualizing international conferences of data management, analytics, and innovation, which has become the landmark conference in the field of data science. She is the recipient of Best PhD Thesis Award, Best Paper Presenter at International Conference Award of national level. So finally, ma'am, it's time for you to welcome you all. Let's put our hands together and welcome Dr. Neha Sharma. Ma'am, and hopefully you are able to share. Future Plus Plus, please stop sharing. Yeah, ma'am, fingers crossed.
I'm sure I'll be able to.
Ma'am, please carry on. Please take over the session, ma'am, please.
I think my screen is visible now.
Absolutely, ma'am. Absolutely.
Yes.
Absolutely. It's visible.
So first of all, let me thank Team Future and Professor Shantanu for inviting me and giving me an opportunity to interact with students, which is one of the favorite things which I like the most. You know, I do not want to leave on any of the opportunity where I get a chance to interact with students. Somehow kind of satisfaction it gives, and you feel like whatever you have earned in all these years, you get a chance to share with them. So topic which I have chosen for the day, after such a fantastic session by Professor Cortesi, we will like to look into data science a bit and try to keep it in very, very basic level. You know, I mean, I do not know how many of you have liking towards data science, how many of you want to get into this field seriously. But whatever you choose, there is a bit of data everywhere. You know, whichever business you go into, whichever domain you like to work into, now every business is a data business, directly or indirectly. So in that perspective, this topic becomes important for everyone, whether you take it as a prime topic, prime domain, or may not be your prime domain. But as I said, like there is a bit of data everywhere, right? So I'll not talk on this slide. This is the same thing which Shantanu has already shared. Just before moving ahead, I'll just share with all of you that recently I have published a book, not recently, last year in fact, a book on open data for sustainable community. Now there we cover three particular case studies, you know, with the help of open data. So that might be one of your interest area to just flip through the book, which collects very good case studies related to open data, especially open data. Right now, let me start with a basic question. You know, what is data science? Now, I will not get into what is data science at this moment. Let's focus only on the word data science and divide it into two parts. right? And let's focus only on the word science. What is the meaning of science? What is the dictionary meaning of science? Is the study of structure and behavior of anything. So if you study the structure and behavior of human behavior, say, it becomes behavioral science. If you study the structure and behavior of, say, earth, it becomes earth science. If you study structure and behavior of objects in space, it becomes space science, so on and so forth. Likewise, if you study structure and behavior of data, it becomes data science. It is as simple as that. Now, why am I sharing this with you? Because once you understand the meaning, probably you will appreciate whatever is being covered, and you will never get confused with people say that Python is data science, machine learning is data science. We will see all your misconception or your myths or whatever confusion you have in your mind will get clear. I'll try to leave you with a clear understanding of what is data science and what is the ecosystem of data science in whatever time is available with you. I would like to start by sharing a survey which was done in the year 2006. Now, this survey was to find out which are the top 10 leading companies of the world, and the result of survey was not surprising. That was the prevalent pattern. There were 5 energy companies and 1 IT company. Can you guess which one could that be? One of you can unmute and share.
Yes, ma'am.
Which was that one IT company which figured out in top 10 list of top 10? Any guesses? No problem. So it was Microsoft. So in 2010, in the list of top 10 companies, there was only one IT company which could make it to it. That was Microsoft. Now, the same survey was carried out in the year 2016. After 10 years. The result was totally different. This time in the top 10 leading companies, we had 5 IT companies and only 1 energy company. Now, what happened in just a short span of time? In just 10 years, what could have happened? Simple. These companies realize that they have the ammunition called data with them. If they explore that, if they experiment with the data, if they apply data science to this data which they have, it has got potential to take them to the leading position, and they all did that, and a reward is for everybody to see, right? So data has got potential to give you unexpected results. So if you look at the data in right spirit and right manner, probably it can make you the leading company of the world also. In the same year, 2016, I was talking about 2016. So let's stay there for some more time. So in 2016, Eric Smith, who is ex-CEO of Google, he gave an interview. And in that interview, he said that right from the dawn of the time, right from the beginning, since the time we started collecting the data till 2005, so right from the beginning of the time, when we started collected data till 2005, the amount of data which we collected was 130 exabytes, right? And now, he mentioned it in 2016, and now every 2 days we are collecting this data. We are creating this data. Now, just to give you the perspective, how much is data? Of course, we all know that it is huge, right? But just to give you a perspective, how much could be that? So A is an alphabet. How much space it will take in your memory? 1 byte. We all know that. Now, if you have 1,000 of those, which can be 2 pages of a book, so we are like increasing it 1,000 times. So 1 kilobyte. Again, increase it 1,000 times. A book with 2,000 pages, right? 1 megabyte of space it will take. Now, if you want to store the human genetic structure, you have to just increase it further by 1,000 times, and you can store all the genetic structure of a human being. It takes around 725 megabyte, which is around 1 gigabyte. So 1 gigabyte is enough to store the genetic structure of a human. Now you will say that 1 gigabyte or maybe genetic structure is not enough to tell you everything about a human. You would like a human being is all about the activities he does, the pictures he has taken, the moments he has lived. So everything has to be recorded. Now, if you want to record everything apart from, genetic structure, it will take 1 terabyte of data. So another 1,000 times, right? So if you consider that a person lives for 80 years and you want to include its or record its the moment which he has spent, the activity he has done right from the birth till 80 years of his age, along with the genetic structure. So everything can be easily fitted in 1 terabyte, right? Now, what is this? This is Amazon forest. Now, Amazon forest is around 1.4 billion acre of land, and in each acre there are 500 trees. Now, if you want to increase the size, volume, another 1,000 times, right? You can see that.
Madam, click
Now,
on hide
just to
button.
give you, okay.
Click on hide button.
Yeah.
Okay. Thank you.
Correct. I think you can see right now. Okay. Yeah. So 1 acre has got 500 trees, and 1.4 billion acre of land will have around how many? 700 billion trees. Now, if you cut those trees into small pieces, please don't cut that. It is just an analogy. Please don't, cutting tree is not allowed. So if you chop those trees into small pieces, put it on the piece of paper, and the amount of papers or the memory which you need to store that, it is that much, just to tell you the size, size. I mean, we are still at petabyte. You increase it another 1,000 size, this is 1 exabyte, everything. Now you have zettabytes and all those stuff. You keep on increasing the size. So what I am trying to tell you is like 130 exabytes of data is being created every 2 days. So much of data is being created in every 2 days, and now the speed recently is furthermore, right? Now, if you do not have mechanism to look into that, is it going to give you anything except for storing it at some location, preserving it? Is it going to give you anything? No, right? So it's very essential that you understand how to make use of the data which you have created. Now, to give you the same perspective, I told you a moment back that till 2005, 130 exabytes of data. 2010, 1,200 exabytes of data. By 2015, 7,900 exabytes of data. And by 2020, 40,900 exabytes of data, which is 40 zettabytes. You call it exabytes or 40 zettabytes. This is humongous, and look at the pace with which it is growing. If we do not have any mechanism to handle it, probably it's not going to serve any purpose. Now, the same thing, what I showed you in the previous slide, has been plotted just to show you that what is the speed of growth. Now this is the data which you have. Okay, if you presume that this is the data you have, only this much portion of data can be processed by data scientists. Okay, further this can be processed by machine. What about the remaining portion of the data? Now, for that you need machine learning. For this portion to be read and understood and find out meaning out of that, or find out insights from those data, you need machine learning. And that's where machine learning comes into play, right? Stay at that, take that point and keep it to you. We'll come back to this, right? So if I tell you the importance of data science by giving you so many examples, amount of data, you might not believe me, right? You have to believe. If at all you don't want to believe me, you have to believe Tim Berners-Lee, who says the data is a precious thing and will last longer than the system themselves. Everything you have, this technology, you have altogether different technology tomorrow. But one thing which is not going to change is the data. Vinod Khosla, who is the co-founder of Sun Microsystem, he says that in next 10 years, data science and software will do more medicine than all of the biological science together. This is very, very important. I just told you that every business is a data business, and data is playing and will continue to play a very, very vital role. So having a basic understanding of ways to handle data will always give you that edge over others, right? Now, to understand all of this and appreciate and then to take the right decision, it is very, very essential to look at the evolution, how we have evolved and how we have reached till this stage. Universe was created around 13.8 billion years ago. We all know that. Earth was created 4.54 billion years ago. Modern human beings, that is we, 300,000 years ago. Civilization started from 12,000 years ago. We are coming closer. Written records are available for 5,000 years ago. Okay. And since then, we have not stopped. We are growing continuously, especially in two areas. One is data and the other one is technology. Data, right from the time we have started understanding things, and we wanted to record it for our benefit in future, we have started collecting data, whether it was on the piece of bark or on stone or on paper or on digital platform like computers or storage, right? We have been continuously storing the data because data is the only reference point which we can go back and refer to, right? But this growth has increased because of internet and social media. You all will agree. There's nothing to disagree about it, right? Every post you do on social media adds to the data. Every likes, every hashtags, whatever, it's contributing towards the volume of data, right? Second thing which is growing is technology, and more because of industrial revolutions. The first industrial revolution to second industrial revolution, 100 years gap. Second to third, almost 100 years gap. Second to third, 60 to 70 years. And now every day it is evolving, Every day it is evolving. We have technologies like Internet of Things, augmented reality, virtual reality, blockchain, drones, robots, 3D printing, whatnot. They are not independent technologies. In fact, technologies are coming together to give birth to third technology. And technology itself is generating lots of data, Now it's the time to define it, to define our understanding for what is data science. Now, this is a simple diagram which when you search on net, you will find it. Now, instead of defining it in words, I thought, let me just explain you with the help of this figure, So data science essentially starts with extracting data, processing it, analyzing it, further processing it, and generating the insights, right? Two things which are not there on your screen. First is identifying the location of the raw data. From where are you going to extract? Okay, first step is extracting the data, but from where you are going to extract the raw data, it has to be relevant. So identifying that relevant location of the raw data, and then once you get an insight after processing, after completing the entire journey, once you get the insight, you need to convert it into data product, right? What's an example of data product? Uber is an example of data product, right? So you can say that data science is a journey of raw data being converted into data product. Everything falls as a part of that journey, whether it can be tool like Python, whether it can be concepts and algorithms like clustering, whatnot, a priori, whatever. They are the part of that journey, right? So from raw data to data product is all your data science. Everything is the companion in that journey to convert raw data to data product, right? Now, from where does this data come from? We all know. First reason for data generation is evolution of technology. Couple of examples for your reference is like telephone. Earlier, telephone was used only for dialing and communicating with your friends, family, right? But now apart from communicating, it is doing so many things. It's recording so much of data, it's creating so much of data, photograph, it works like camera, so much of data with this evolution also. Laptop or desktop, which was there with limited processing power, limited space, limited everything, limited, now there's no limit. Everything is on cloud. There's limitless space, limitless processing power, right? And again, limitless data. Car, which was essentially a marvel of mechanical engineering, now along with mechanical engineering, computer science engineers, data scientists, all are part of it. So car is no more a mechanical engineering marvel, it is also a smart car. So with the advancement of technology, whatever advancement you are doing with the technology, it is also generating and contributing and adding to the data source which you have. Second and very obvious is IoT devices. Everything is now embedded with IoT devices, which essentially have got sensors, actuators, networking capability with which it exchanges the information on its own without our requirement, human interference, right? If you have to, your refrigerator fitted with IoT will automatically order to a grocery shop saying that, okay, my level is like crossed, now it has to be refilled, right? So likewise, IoT, again, it's creating, because of sensors, recording, exchanging, lots of data is being generated. Social media, you all know, we all are contributing, we are the culprits for this source of data, right? As I said, one like, one hashtag is the data source. Other factors like contemporary, which are prevalent since ages, like retail system, banking system, media, entertainment, healthcare. So those continue to generate data, right? And most important and most recent is open data. Open data is the data which is freely available. And who makes it available? Either the government organization or few corporate sectors, for whom, basically for researchers, where you can download the data, do something. If you get some insight, you can share back with the government, and so on and so forth. So this is a very good resource which is available. You can figure out with data.gov.in in the state level, like in Pune. We have our municipal corporation providing us lots of open data about say green cover of the city, pollution level of the city. So likewise, whatever may be your area of interest, there's open data available to you. You need to search. Not only in your country, it's available across globe. If you want to compare your traffic situation with Germany's traffic situation, your transport situation with Germany, so you can download the open data from both the countries, compare and come out with some insights, right? Now, what is the need for data science? You have data. What is the need for data science? As I just now told you, because of the revolution of technology, we have got lots of data. The data flow is continuous and in huge volume, right? And most of it is unstructured. And there's no dearth of space. As I told you, like we are sufficient with space. With framework like Hadoop and Spark, we are now comfortable to store big data comfortably, right? And process it also. But what we lack is the predictive analytics capability, right? And then scientific insights. But if the same data is being used for decision making, for making some predictions, or for finding out some innovative patterns, then you can easily say that you are in the realm of data science. Now, I'll give you a small example, like traffic data. Traffic data we have been collecting since ages, we were not utilizing, right? But now, the moment you have to travel from one location to other location, it will tell you complete route. Route number 1, route number 2, route number 3. It will predict ETA for you. It will also tell you that, okay, this route is congested at this location. You will take your ETA might get increased, or if you follow this route, your ETA will be this. You follow route number 2, your ETA. So much of insight is getting generated. So same data is now helping you take some decision. It is predicting some things for you. It is giving you some patterns, right? Now, the same thing, I would just like to share the same thing with the help of another perspective. It's the same thing. So, olden days when we had only structured data. So, structured data means tables and columns. I mean, rows and columns in the form of tables. Some structure to your data set, right? Now, if suppose you're running a company, you have multiple branches, so you would like to collate all the data from multiple branches so that headquarters can have a collated view at your data set, right? So what will you, where will you collate? What will you use to collate? Certainly data warehouse. Now, data warehouse is again a structured form of storing data, right? And what tools you can use? It's traditional BI tools, business intelligence tool, right? And what kind of report you can generate? Some predetermined report. Some predetermined report, when I say, it's like what was the sales last year, who was the best salesperson, salesman of the last year, what was the maximum profit of the company, which product didn't do well last year. So something predetermined can be extracted from this particular data warehouse. What is the situation now? Now you have unstructured data also along with structured data. There is no dearth of storage, because of the frameworks like Hadoop, Spark, you can store it in distributed manner across distributed place, right? Now you have data science algorithms also, which will allow you to forecast, which will allow you to predict, which will allow you to find out trends, which will allow you to find out clusters, which will allow you to find out some rules, and those things will help you having the scientific discovery from your data, right? So need of the data science is mostly because of the volume of the data which you have. If you do not, I just showed you the diagram, a couple of slides back, that this huge chunk of data which cannot be processed by us nor by the machines, for that you need some specialized mechanism, that is machine learning, right? And of course, that helps you in generating lots of data, that helps you in uncovering the patterns and trends in data, that helps in taking very, very relevant decision about your data, about your future, and helps in solving complex problem. Complex problem can be as complex as detecting genes linked to deadly disease, building a self-driving car, building a face detection system. So data science, as I told you, it's everywhere. Whenever you play with the data, you are in the realm of data science, right? Why it is so exciting? See, anything is exciting only for two reasons, First, what kind of job it has to offer to you, whether it has got plenty of opportunity, and whether it has got plenty of opportunity to work on exciting projects, So first is your job surety, and second is kind of work which you are doing. Data science fares well in both the areas, it's ample job available. In fact, when you get recruited, get recruited on the higher salary than your companions, and I'm not saying this is a source which I have put in front of you. It's from that source, right? And then you will find lots of articles on net, how much job, which is the hottest job, and all those things, right? So it has got a surety, it gives you a surety of job at least. And second thing is like kind of job you do. First was like whether you have job or not, the kind of job you do. So as I told you, like every business is a data business these days, whether you get into travel, healthcare, marketing, automation, social media, credit, insurance, what all you do, you are essentially, when you are dealing with data, you are doing data science. Whether you call it data science or not, you are essentially doing data science, right? Let me give you a couple of examples, interesting examples. You all must have heard of this Google flu trend. Now, what is this Google flu trend? Flu trend is a job of CDC, that is Center of Disease Control, which is there in every country. The job of CDC of any country is to identify where any flu has occurred, in which corner of the world a flu has occurred, and keep a track of it, how far your country is close to that country, what is the chance of getting infected. So they keep a record of it and maintain their data set. They maintain it once in a week, right? Once in a week or once in a fortnight. So finding out flu trend is the job of CDC, whereas Google search, Google's job is to search, it's a search engine. Whereas Google flu trend is nothing but a simple web service. What it does, it identifies all the searches which has come with the word flu from any country, and then it aggregates a similar kind of search, find out IP, and then try to find out the correlation, from where these searches have originated. With the help of IP it could do, and what are the flu cases. So it's a simple thing, and it does faster than what CDC does, and it is giving you accurate results also. This is one of the first data science application which was recorded. You can read more about this on Google, right? Second most popular example, which one sir, like before me, he said, like a recommendation system. Now most of the businesses, so like Amazon, Flipkart, Netflix, are working on recommendation system. Their recommenders are so powerful that you don't even realize that whatever you are not doing anything, you are just following the recommendation. It's so perfect that probably if you would have thought about things independent of those recommendations, you would have thought about that, right? So Netflix, most of the things which you watch on Netflix is basically recommended by that. This is an example of data science. Amazon, as I told you, its recommender system is so strong that it follows you everywhere. If you want to buy a pair of shoes, and you search for it, right, and you come out of that app or maybe site without making a purchase, next day when you go to YouTube, you will see that those pair of shoes are being recommended to you. It's following you. You ignore, you go to Facebook, again you will find that those pair of shoes which you had selected yesterday still following you. So you are not going to a shop is following you depending on your liking. And maybe if you could not take the decision yesterday, probably it will tempt you to purchase, now when it is following it, right? So how does it how it finds out, like what is your liking, what is your taste, and how does it recommend? So basically it's like it collects lots of data about people, even they purchase the data also to understand, to know more about you. They sign a deal with your company and then they take all your data, right? There's a new concept of marketplace where data is bought and sold, right? So they have a huge data set of all of us, right? Then they keep looking at your browsing pattern, which all sites you browse. They keep on watching their purchasing patterns. What is that last purchase you do? Then they also have the details about your demographic information, what age, what gender, what is your salary package, and accordingly combining all these things, they recommend you something which is almost perfect. This, in fact, at times you tend to feel that this is what I was looking for. So very, very strong case for data science. Facebook tags, the moment you upload your picture, it will start tagging it, with your start matching it with your friends, families, and most of the times this is also correct. This is again an example of data science. Natural language processing, which is used here. Amazon Alexa, you keep on using it for playing music, but apart from playing music, it does so many things. And again, it's an example of data science. I'm just going slightly fast in the interest of time, because my interest is just to let you know that things which you're dealing on day-to-day basis are an application of data science, are an example of data science. Spam filtering, especially in Gmail, you will find that all your mails and spams are filtered. This is again an example of machine learning, natural language process, and intern data science. Uber, I told you it's a data product. Uber is an example of data science. What made Uber so rich? It does not own a single car. So of course the question of car or maybe having the infrastructure makes them rich. No, it's their service which makes it rich, right? So how do they provide the service? Certainly with the help of data. Is data enough to grow the business? No, certainly not. You have to play with the data. You have to find out useful insight to solve the problem with the data. Then only data can find out solution and make you the rich company, right? As that of Uber. I'll give you one example. This is not a unusual thing. You and me, we are facing this every day in and day out. Now, in the morning, especially in the wee hours, when the traffic is too much, everybody has to go to school, everybody has to go to college or to office. At that point of time, when you try to book a cab, it will show you higher tariff. So when it will show you higher tariff, when the load is more, when the demands for cab is more. So it's a demand supply problem. So morning, in certain slots of time, you will find, and also in the evening, you will find that the tariff which it is showing is on the higher side. Now, why it is so? It's just that when there's more demand, the tariff is higher. It's just as simple as that. No, there is a algorithm which gets triggered, when there is more traffic. So the moment Uber realizes that in this particular cell, they have divided the geographical area into cell. This particular cell has got more demand of cabs, then to motivate the drivers to come out on road from maybe from different cells, maybe from further distance, to serve them at higher price is the purpose of this algorithm. So basically this to address this demand supply problem which is faced by Uber, and to serve. And it does not happen randomly, everything is captured and then it is delivered. It will not happen on like when you do not have traffic. A non-traffic time, you will find that the tariffs are as usual because you will have sufficient number of drivers and cabs available in your area. This is just to motivate drivers to come on road, and then probably you will get better paid, for that service. So this is a fantastic example of data science by a Uber product. Of course, your Apple Watch, which keeps on recording everything, your heart rate, your sleep cycle, breathing rate, everything, blood pressure. And the moment it sees any aberration in that pattern, it triggers an alarm, and there are many stories around it, I'll not say stories, there are many facts around it, that the lives have been saved because of this, because of the trigger at right time, right? Very interesting example here is US election 2012. If you all remember, I am not sure whether students will remember this or not, but faculty members will certainly remember. This is the time when Barack Obama contested for the first time and Romney was the opponent. Both of them were contesting together, and both of them like adopted the contemporary style of campaigning. That is like you address mass gather, then you design some say video clips and then circulate that. All those things were being followed by both the parties. One special thing which Barack Obama did was to form a team of data scientists, and this team was working at the back end without anybody knowing about that. They took the entire census data, cleaned it, processed it, identified that there are so many people who were duplicate in that particular list. There was one city which was not even captured, so they found out all the discrepancy in the data and then corrected it, reached out to people, helped them by solving their like concerns or maybe grievances, and then promised them that if they are elected, probably all their grievances will be resolved, and encourage them to come out of their homes and vote, right? And rest is all history, and that's how Barack Obama won. And the person behind that particular election win was nothing but Nate Silver. And that was the time when for the first time a data scientist was appointed by the White House, and he was nobody else than an Indian, and it's a job on you that you have to find out who was that Indian who was appointed in the White House as a data scientist for the first time. Another example is like PageRank. So website is no more a place to just share the information, communicate, talk. It's a proper business network. So any website with high page rank clearly indicates that there is lots of traction on that website. So if you want to advertise your product, right, you would like to go and advertise on that. So and it takes network analytics into practice for achieving this, right? Driverless car, I have already told you, like, this car is no more a mechanical device. It is fitted with so much of sensors, cameras, gadgets, which keep on exchanging so much of data, and the car becomes self-aware. Car exactly knows what is on the left, what is on the right, what is in front, when to put brake, how much speed it should take. So the intelligence in car is brought by lots of devices and also with the help of data. Sports analytics is another upcoming area where it's giving us very good results. It's the area of research also, with so many sensors being fit on the cricket bat. If it is cricket, the cricket bat, your stumps, and every devices, everything which is there available on the playground, everything is fitted with the sensors. Even people wear it on the wrist also, so that it can monitor the way they play. All the data is captured, and it is basically used not only to improve the individual game, it is also used to plan the strategy to win the game, right? So very, very important area, interesting area rather. Now, as I promised, I'll tell you about the ecosystem of the data, which is very, very important, and it's very essential for all of us to understand it in the right way, right? Now, if suppose, do I have 5 more minutes to wrap up?
Yes, ma'am, please.
Yeah. So if you see this sphere on the screen, or circle, let me call it circle because it's 2D. So a circle on the screen as a world of data science. Presume that this is a world of data science, right? So what happens in that world? So how you enter into that? There has to be a problem for you to solve, right? Otherwise, why you will play with the data? If there's no purpose, why will you play with the data, right? So for that, it is very essential for you to understand what is the problem. How will you understand the problem? When you talk to the people who are suffering from the problem. Now, problem can be business problem, it can be social problem, it can be government problem, it can be administrative problem, it can be any type of problem. But for you as a data scientist, or maybe somebody who is trying to solve this, try to find out a solution with the help of data, you need to understand what is the problem to be solved. Because if you do not understand the problem, what solution you will find, right? So do not hesitate to talk to all the stakeholders to understand the problem. Formulate your problem very neatly, right? Now, once you understand the problem, you will have to find out from where you will get the data to solve this problem. So it essentially might not be available at one location. It may be distributed across location. You have to search web servers, logs, databases, APIs, online repository, maybe open data, right? So you have to search for the data everywhere, wherever it is possible. Your client may provide you data, may not provide you data. So it's your job to find out the data, right? Then data might not be ready to use. It's not MTR ready to cook. So data might not be ready to cook. You have to prepare it. So maybe in your data set, you will find that one column is all blank. What will that help? That column will not be of any purpose to you. So better to drop that, right? You will find the other column with maybe 90% of data filled in, 10% of data is missing. So then you have to recreate those 10% of data. You can adopt multiple mechanisms to recreate those data, right? You need to transform your data set. Suppose your problem statement requires the month portion of the date, whereas your data set has got timestamp, which has got everything, So extract the month portion of the date from the timestamp and store that, because you want to use just the month portion, right? So data has to be clean, data has to be transformed as per the requirement. Then you have the data with you, but data does not speak on its own. You have to perform some exploratory data analysis. Now you call it exploratory data analysis, you call it descriptive data analysis, you call it analysis, whatever you want to call, you can call it. You can call it statistical data analysis also. So whatever you want to call, essentially you are doing it's exploratory data analysis. Your simple data roll-up data, a simple basic mechanism to be applied there to understand the structure and behavior of data. Now, if you feel that, okay, my data is ready, clean, neat, I'll go straight away build a model. If you try to do that, you might end up choosing a wrong feature for your data to build a model. And then your entire purpose will get defeated. So I would advise that exploratory data analysis is very, very interesting step, very, very simple step. It will help you build up a model. So do not skip that, right? Then go ahead, build a model. Depending on the type of data you have, whether you have supervised data or unsupervised data, decide what algorithm you will use. And there's no mantra. There's no mantra that if you have structured data related to green cover, go and apply this algorithm and it will give you result. You have to apply all the algorithms which are relevant and compare the results, and then the one which is working fine should be taken as a model, right? Of course, the method is you divide your data into test data and training data. Training data is used to build a model. Test data is used to test a model. And then finally, your model is built. So once your model is built, you need to convey to your customer or for whomsoever you are doing this, through visualization and good communication. Now, once you have done that, your customer, client, your end user is convinced, then go and deploy it. And story does not end there. Once you deploy it, you have to observe it, you have to maintain it. Now the data which was historical data in your system, in your model, it will be replaced by your real-time data. And then you have to again see whether your model is functioning as per expectation or not, right? So I'll come back to this sphere again. So data science is the bigger sphere. Inside that you have a smaller sphere called data analysis, then data mining, and then text mining. So from where you will start, as I told you, you will start with the data. Data can be structured, unstructured. Pull out all the relevant data after understanding your problem statement. Extract all the data which is relevant, okay, and then prepare it in the form from where you can perform the analysis, right? Then you enter into the data analysis phase, which you call it exploratory data analysis, descriptive data analysis, statistic data analysis, or simply data analysis, right? So you take the same data which has been prepared and try to find out some patterns, some trends. Basically, you are trying to understand the behavior and distribution of data, right? So data analysis essentially is on historical data to understand the behavior and distribution of data. Now, having understood that fairly well, you would like to use that understanding to know the future, right? Past samajh mein aa gaya, abhi future samajhna hai, right? Again, you will use the same set of data. And to know the future, there are two ways. First, either you make use of advanced statistics, right? Like regression, clustering, time series, and try to do prediction, forecasting, and so on and so forth. Other ways to make use of machine learning. Now, machine learning, all of you know, is the part of or subset of artificial intelligence. Now, artificial intelligence basically is an attempt to make machine think, behave, and understand as per the human being. And the first step towards achieving this is with the help of machine learning, right? So here what you do, you try to train machine to learn on its own. If I have to explain you in simple way, right? And there are so many algorithms of machine learning, and one which is called neural network is based on human neural network, where you get the input, you process that input, and add on your experience and then take a decision, right? That is one of the algorithms, right? And then when you do processing multiple times with multiple purposes, it becomes deep learning. So neural network is input, process, output, whereas when you take input, process, output, that becomes deep learning. If I have to explain you it in simple way, just to tell you that, right? So data mining, which is essentially for futuristic looking, you want to find out some, you want to predict something, you want to focus something, you want to find out some association, you want to find out some cluster. So whatever you want to do, it's either through advanced statistics or through machine learning. So you may adopt advanced statistics, you may adopt machine learning, but essentially you are trying to peep into the future with the help of data, right? So essentially, if I have to simplify this, when you have a manageable amount of data, you go for advanced statistics. When you have big data, you go for machine learning, right? Now coming to text mining, so most of the data, as I told you, it's in unstructured form, and it is in unstructured textual form, whether it is your mail, whether it is your tweets, whether it is any document, it is essentially text unstructured form, right? Now, how to analyze this? Machine learning will take some structured format. So there fits in between natural language process, which converts this unstructured data, unstructured text into a format which is easier for machine learning to algorithms to analyze, right? And then once you have done everything, it's time to visualize, to show it to the world that this is the result I have got, good, bad, ugly, right? Now this complete ecosystem, when I say, now you can see and you will argue with me that, okay, then artificial intelligence, machine learning is out of this. No, I could not draw this. Now this I have not taken from any book, so I could not do that, but I urge you to presume that this entire screen is your data science and everything is within that, so this comes as tool, that comes as technique, this comes as algorithm, that is the data, everything sits within the world of data science. With that, I hope I have conveyed and simplified the ecosystem of data science for all of you, and I would like to stop here. Thank you so much. My email ID and phone number is there on the screen. In case if you feel or you have any doubt about this, you can reach out to me directly also.
Thank you, ma'am. First of all, a big thanks to you for waiting. We had a technical hinge of 10 minutes, and amazingly, both the speakers have kept themselves within the time frame. That's a great thing. The session was really illuminating, and actually, we had a talk yesterday evening that most of the students are from UG backgrounds, first year, second year, even the school students are there. So hopefully that would be very much helpful in sparking the quest for data science among the students. Without further ado, let's open our QA session. I would request the participants to raise their hands, please, if they have any question. We'll take a couple of questions before we head on to the final segment, that is the vote of thanks. Yes, I can see Dr. Monalisha Ghosh, Joint Convener from the Computer Applications Department. Ma'am, please go ahead with your question.
Once again, I want to thank ma'am. Thank you for a beautiful session. Ma'am, as we know that data is one of the most challenging area nowadays. And we know that there are huge amount of, vast resource of data are available, and most of them are unstructured in nature. So I have little questions to you, that as you are a data scientist, so what are the most challenging problem you encounter in your work as a data scientist?
Most challenging at this point of time is climate, Sustainable development goals are important. Climate change is important. And we are also trying to solve or come out with some solution which can help climate change to stop, Of course, stop is not possible, but to minimize. So if you ask me, and like which are the challenging areas, climate and sustainable development goal, it is very, very urgent for all of us to address this in whichever way, whichever area we are working. These two have to be kept at paramount.
Thank you so much.
do we have any more questions from the participants?
Don't worry, Shantanu. If questions are not there, probably they can reach out to me later also.
Yes, yes.
Because
We can reach out to you in offline mode also.
yes,
Ma'am,
yes,
we all know that you have been an integral, in fact, an instrumental part of Society for Data Science, the first kind of body for the entire nation, combining of the collaborating with the academicians and industrialists from the domain of data science, and found the secretary of S4DS. On behalf of the organizing committee, we have an appeal to you, and we have our joint convener, Dr. Joydeep Nath, to pose the appeal on behalf of Team Future. Professor Nath, if you can please go ahead.
Yeah, yeah. Thank you, Shantanu. I think I am audible.
Yes, very much so.
yes, yes.
Okay. So, thank you, respected Neha ma'am, for your mind-blowing and interesting speech on data science and its application. Nicely you have explained about the data science and its application using some very real-time examples. It's really interesting. Once again, we welcome you in our lecture series program Future Plus Plus, organized by Team Future. We are very much delighted to have you within us. On behalf of Team Future, we have an appeal to you that as you are the founder secretary, ma'am, Society for Data Science India, we are very much interested and eager in setting up a center of excellence, students chapter, or any kind of collaboration membership with S4DS and our departments like computer science, CSE data science, CSE AI/ML, CSE IoT at Future Institute of Engineering and Management, and also at our another institute, Future Institute of Technology. Ma'am, if you please guide us how to move on, and then we'll be.
Certainly, certainly. We can discuss it offline. Maybe its process is simple. The way you go ahead and take IEEE membership, it's almost similar, except for the membership fees. It's almost, the process is almost similar, and I feel like it's must. The kind of importance it is gaining, not only
Yeah,
at national level, at global level. It is must that we be in that network. Being in that network will also helps. At times it helps. So it will be a good move. We can get connected. Shantanu knows me personally, so
okay.
we can form, go for a meeting
Ma'am,
and finalize. We
soon
are
we will
always
contact
there. Yes.
you in this regard. Okay.
Yeah.
So thank you, ma'am. Have a nice day.
Thank you. Thank you so much.
Thank you, ma'am, for accepting our invitation. Yes, we know you were in a very, very busy schedule to match with the actual timing. You said at the beginning, I have a close schedule, but let's close on to the 24th schedule, which you were asking. Yes, ma'am, on behalf of Team Future, our executive director, sir, to appreciate our speakers, will send a letter of appreciation to both the speakers. That's what we can say. So, once again, moving on, let's now have a look at and have a go at our valedictory session. But before doing so, let's hear from another convener, Dr. Anirban Chakraborty, Head of Computer Applications Department, about the role of Computer Applications Department, MCA BCA, and taking this event further forward. This is Future Plus Plus. May I request Dr. Chakraborty, please comment.
A very good afternoon to everyone. Myself, Dr. Anirban Chakraborty, Head of Computer Applications Department, extend a very hearty welcome to all the esteemed guests and participants in this event. The MCA and BCA programs commenced in the year 2007, and since its inception, our focus was to deliver high-quality technical education consistent with the industry requirements. The Computer Applications Department has a great ecosystem of meritorious students, competent faculty, and high-end infrastructure for creating a conducive environment for academics and project work. In the recent past, the department has produced university toppers, and its alumni members are now working in top of the line IT companies, and some have also become successful entrepreneurs. Apart from university course curriculum, we have frequently organized national seminars, workshops, value-added courses for our students and faculty members to imbibe in them the recent trends of technology and their applications. We had organized faculty development program with hands-on workshop jointly with the University of Calcutta on data analytics using R. The lecture series Future Plus Plus is a step ahead in this direction, where the participants will have the rare opportunity to hear from stalwarts and meet the stalwarts in the area. Software management and machine intelligence have accounted as an integral part of every sector in our life, be it finance, healthcare, to customer management. Today's lecture from the revered speakers will definitely motivate us to explore new avenues and applications in this domain. Thank you.
Thank you, sir, for your illuminating word, ma'am. We may remind you, we had this professional student chapter with S4DS with the computer applications department a couple of years back. So we may further continue with the new departments like computer science, data science, which was inaugurated in 2020, and all the other departments in our second campus, that is Institute of Technology. There we have artificial intelligence, machine learning, IoT, blockchain, cyber security. So we are hopeful that we will have a further fantastic bondage and relationship with S4DS in the coming years. Don't go too far ahead, sir. I would request Dr. Chakraborty to present the vote of thanks on behalf of the organizing committee of this first edition of Future Plus Plus lecture series. Sir, can you please take over?
Thank you, Professor Shantanu Roy. I am privileged to give the vote of thanks for this international event. We thank Honorable Sri Shilajit Ghosh, Chairman Team Future, and Dr. Moushumi Ghosh, Founder Director Team Future, for their inspiration and support in organizing this technical webinar. We are indeed grateful to our Executive Director, Dr. Alok Ghosh, who have been a constant motivation for us in organizing such seminars, guest lectures, and technical exhibitions throughout the year. We are indebted to our eminent speakers, Dr. Agostino Cortesi, Professor, Ca' Foscari University, Venice, Italy, and Dr. Neha Sharma, Consultant, Tata Consultancy Services, for sparing their valuable time to deliberate in today's inaugural lecture of Future Plus Plus on recent trends in software management and machine intellectuality, and enlightening us in this area. We are indeed grateful to our sponsors, Arden Computec Private Limited, for supporting us in this inaugural event. I also take this opportunity to thank the conveners of this event, Professor Taposh Roy, HOD, Computer Science and Engineering Department, Professor Prashanjit Basu, HOD, Information Technology Department, for their prize supervision and technical recommendations in making this event feasible. We are also thankful to the joint conveners, Dr. Joydeep Nath, Professor Rabindra Kumar Yadav, Professor Prashanta Majumdar, Professor Debjyoti Basu, for their guidance and valuable suggestions. We are extremely thankful to Professor Shantanu Roy, HOD of Computer Science with Data Science Specialization, for superbly hosting this event and making no stone unturned in organizing this international seminar. I extend my thanks to all the organizers and staff members of Computer Science and Engineering, Computer Science with Data Science, Information Technology, and Computer Applications Department for their valuable and meticulous contribution in this event. We also humbly thank the library and system department staff members for their technical assistance. Last but not the least, I would like to thank all the student volunteers of this organizing committee who have given a commendable and sincere effort for making this event a grand success. Hope we meet very soon in another inspiring talk of Future Plus Plus lecture series. Before ending the session, I would like to request all participants to fill up the feedback form. Then the participation certificates will be sent to the respective mail IDs. Thank you. Have a good day.
Thank you, sir, for wonderfully presenting the vote of thanks. One name got under mentioned, and that is the name of Dr. Anirban Chakraborty, Head of Computer Applications and convener. You have been instrumental. You have been the motivating factor, the nucleus of the entire cytoplasm of all of us, the young faculty members, the junior students, and you have been the source of inspiration all the way through in the history of Team Future. So, with this, we are almost on the verge of ending this event. It goes without saying that with the help of the students, it was impossible for us to start our journey. But it is just the beginning, just the end of the beginning, rather. We would like to go forward with this Future Plus Plus lecture series in the coming days in blended mode, be it physical, be it be it in the online mode. So with this, let's have a pledge that we will continue this event in the coming days and we will make our future even brighter. Thank you all. Hope to meet you again in very close proximity once again. As Dr. Chakraborty said, the feedback form is being pasted in the comment box, in the chat box, and it is reminded once again the participation certificate will not be shared unless you fill in the feedback form latest by 9 p.m. tonight. After 9 p.m., the feedback form will be inactive. So be careful on the timelines. Be safe. Be happy. Hope to meet you again in future. So that's all from Team Future. Hope to meet you again with Future Plus Plus, the another series. This is Shantanu Roy on behalf of the organizing committee of CSE, DS, CSE department, IT, and CA department, bid you for the final time. Thank you very much. Have a very good night. Thank you. This ends the session. That's all we have for today. Thank you very much. Let's leave now.
Thank you.